everybody. Let me, sharing PowerPoint directly wasn't coming up as an option, which is unfortunate. So I'm just going to share the, the desktop, and I'm sure not my first choice, but that's the way I'm going to do it. So we should be all set now, and I can still see the chat. So yeah, in my role at CloudFactory, it's basically an evangelist role, meaning that I work with the marketing team and doing events and so on. My comments today won't be, for the most part, specific to CloudFactory. What I really want to talk about today is data annotation and human in the loop, and how it's been a bit of a journey, even for myself, for the last year and a half, to learn about this whole new world. I've been building predictive models for about 25 years now, but I've learned a lot about human in the loop and data annotation. And as I talk to my colleagues, including quite veteran colleagues, they also mention that this is very often an area that they're not very familiar with. And then if they get into a project that has elements of computer vision and so on, they suddenly discover that data annotation is a big part of it. So let's jump right in. What I want to start with first is what I think was a really critical milestone for our community in 2012. We've been living with deep learning now for several years. So I think we forget, particularly perhaps if you don't have the perspective of a number of years, that we've always been doing neural nets and deep learning. But as many of us know, neural nets really kind of have come in and out of fashion over the years. People talk about AI winters and so on. So the critical year, I think, is 2012. And why is that important? We want to spend a couple of minutes on that. Well, ImageNet, and a number of you are probably familiar with ImageNet, is really two things. It's a database, and Fei-Fei Li at Stanford has become really a machine learning celebrity over the years because of her important work on ImageNet. So it's simply a database of labeled images. But as many of you also know, it's also a competition. And the competition started in 2010, but 2012 was a really big deal. And I think it's changed everything. And again, I've been doing this since the late 90s. So I would say around 2015 or 2016, for a few months, I became incredibly interested in this because I was wondering why all of a sudden neural nets weren't just back in fashion, but they were dominant. We're also going to be talking a little bit about how their dominance is really in some application areas more than others, and just a little bit of the backstory of why that would be so. First, though, I want to handle a little bit of mythology around this. As practitioners, as most of us are, we probably know that the real story is more complicated. But when you talk to middle and senior management, let's say, for instance, I'm talking to a client and I'm perhaps chatting with not somebody like a VP of analytics, but perhaps their boss. And you'll often hear these kinds of phrases that, computers are learning like babies, or like puppies. And then another one that always gets my attention, that the models get better and better over time. Now, clearly, if you're improving the data and you're rebuilding the model, that's true. But in supervised learning, which is the vast majority of the models that we build, whether they're deep learning or traditional things like decision trees and so on, which we forget people are still doing. There's a lot of industries where those traditional techniques are still the dominant ones. But in supervised learning, models actually degrade, not get better. So this notion that we just kind of release the model on the world and it interacts with the data, and we step aside and have our lunch, or perhaps even go home at night and come back to our work the next day, and the model's getting better and better every day. This is the way people envision it. It's really not true. Supervised models are really about as good as they're going to get on the day that they're born, and they actually degrade over time. Again, unless we take action. Data does indeed accumulate. So if we leverage that and rebuild the model, we of course can build a better model. But if we don't take action, it actually degrades over time, not gets better. So I think what's going on actually is the folks that will make these kinds of statements are confusing supervised learning with reinforcement learning. And reinforcement learning, of course, is fascinating. We hear about reinforcement learning with things like computers beating humans at chess, or more recently, and I think really interesting, computers beating humans at Go. This is fascinating stuff, and it's in the news. So people hear about reinforcement learning, even though the dominant one is still supervised learning. So what does that have to do with our journey today? Well, the thing about supervised learning is you need these labeled data sets. You need images and labels, or increasingly these days, you need labeled video. And you don't just stumble upon that data, you have to craft it. So back to why 2012 was so important. In 2012, Jeffrey Hinton and his team won the ImageNet competition. And they didn't just win, they won in a dramatic way. Two things about their win was dramatic. One is they used a neural net that had more layers than the winner the previous year, substantially more, as we're about to see. And that's, of course, why we call deep learning networks deep. That's what's deep about them, is they have hidden layers, more hidden layers than usual. When I was starting out with neural nets, when I first learned them, much earlier in my career, we were told sometimes you had 2 hidden layers, most of the time you had 1. And if you had 3 hidden layers, the feeling was either you were kind of showing off, or you were incompetent, or both, or something like that. It was really frowned upon. And now, of course, we have an enormous number of hidden layers. So clearly something's happened. So not only did they use more hidden layers than the previous winner in 2011, there was a huge leap in performance. Take a look. So the first 2 times that they did the competition, they had 2 hidden layers. Then the year that we're talking about, 2012, they jumped from just a couple to 8. And then look at the explosion. Now notice, by the way, this chart ends at 2015. That was now quite a few years ago. There's an enormous amount, and many of you perhaps have been involved in deep learning networks that are complex like this, but it's really changed everything. Now, when you learn traditional techniques like regression or individual decision trees, again, techniques that we might be tempted to think of as quaint, but they're still very much in use. And certain industries where you need transparency and you can't do things like XAI, they really still dominate. Well, when you're using traditional techniques like that, you learn about ratios between the parameters that you're trying to fit and the number of cases that you need. All of those rules really start to break down with deep learning, but nonetheless, there's still some relationship between number of parameters and, and sample size. And these layers are not the parameters. They're almost more like like adding a cube to a polynomial or something. It's exponentially increasing the number of parameters when you go from 7 layers to 8, or from 8 to 9, and so on. So as you've probably seen in the news, there are deep learning nets now with billions, actually, just within the last couple of years, trillions of parameters. Well, those kinds of models are very hungry for data. And this was a video that was done some time ago, but I encourage you to find it on the web because I thought it was incredibly well done. And of course, Andrew Ng is a machine learning celebrity as well, but he uses this really straightforward metaphor of deep learning networks being like a rocket ship. You know, that the reason that we're talking about deep learning now and not 20 years ago or not 30 years ago is it's a convergence of a bunch of factors. Almost all data now is digital, so our data sets are larger, okay? And then, of course, we have more powerful computers, all quite obvious, but it's really only in this environment of these much larger labeled data sets and more powerful computers that deep learning was working. I mean, Geoffrey Hinton was incredibly persistent over many, many years trying to get this technology to work. And these factors just weren't in place 15 or 20 or 25 years ago, even though deep learning has been a research area for a quarter century. It's really only in the wake of this competition in 2012 that all the pieces are coming together. So I love this metaphor. The notion is if you're going to build a big rocket, you need a lot of fuel. And the big rocket is the complex deep learning network. And the fuel is the large data set, obviously in the form of labeled pairs. So this has created a whole cottage industry. I mean, really rapidly growing companies. CloudFactory, for instance, happens to be one of them that is supporting the data side of this whole infrastructure because there's an endless need for these large labeled data sets. And in the industries that I've worked in most of my career, manufacturing, banking, billing models like insurance fraud and so on, you don't have images. So you're not labeling it hot dog, not hot dog, to use the famous example from the television show. So that data is already structured, and this is one of the reasons that there's such a need for these labeled data sets, because where deep learning has really thrived has been audio, visual, visual images, computer vision, and video, in support of things like your smart device or autonomous vehicle research or things like delivery drones, which are obviously in our near future, bringing you takeout, things like takeout food or delivery, during this period that so many of us have been working from home exclusively. I can only imagine, I haven't researched it, but I can only imagine the amount of parcels that have been shipped the last couple of years and how that might compare to 2009 and earlier, or 2019 and earlier. But it's not just about training data. It's really the entire life cycle. So training data, of course, is important during design and build, but there's also instances where in assembling and using these data sets, there become issues where you need actual human manual work to complete holes in the data set. And if you haven't worked in this area or worked on a project where data sets like this are required, you may not have a rich sense of just how much activity there is doing this, or how difficult it can be to manage potentially hundreds or thousands of people doing this kind of annotation. So I love quoting my friend and colleague James Taylor on this, because he's very much a traditional industry guy. He sometimes describes his clients as, I love this this phrase, and he says it in an endearing way, big boring companies, companies like big insurance companies and so on. And folks are afraid that, they've got to postpone training, the model until they get some big, data set. And what he likes to point out is there are things that you can do while you're building the model. You don't have to wait. And to give you a notion of what that might be, take a look. There might be a coffee stain or something on this receipt. There may be some reason why it needs an exception process, and a human comes in and assists the computer. But that doesn't mean that you can't have an environment where 95% of the cases are done by OCR. And by the way, if you think that OCR is technology that's completely mature and 100% accurate, it's just, you would think so, because we've been doing OCR since the 80s, but it's just not the case. So what James would argue again is that what you want to do is create exception processing, and while you're doing so, you're increasing the quality of the data set, rather than doing, let's face it, as data scientists, a lot of times we tend to have a bit of a perfectionist streak. And we don't want to deploy until the model's either perfect or pretty close to perfect, and we're just never going to get there. So you really have to come up with a way, when you're dealing with things like OCR or computer images or video and so on, to build the best model you can, also have exception processing plan, and make sure that you have the proper feedback from the exception processing back into the data set. I had noticed, by the way, that a hand went up, but I imagine that the best way to proceed is to take questions at the end, unless it's a point of clarification. Let me take a quick look. I'm looking at this and I'm not 100%.
Now you go to the Q&A.
Yeah.
There was a question for the previous speaker.
I see. Yeah. That's what I gathered. I'm glad that I asked. I thought I saw a hand. Oh, I saw a hand raised. That's what prompted me to take a look at it. But I'll continue there. Got the mouse in the wrong place. Okay. So what I want to talk about now is that you would think that this goes hand in hand to such a degree with deep learning, that we'd all be learning about data annotation and all this stuff in our data science master's programs or what have you. I do some work with UC Irvine's predictive analytics certificate program, and I know that we don't talk about this at all in this program. There's just not room for every topic, but this is becoming increasingly important. And what Robert Monarch, who wrote an excellent book on human in the loop, by the way, he and I were in an interview together, and he mentioned that most people enter the workforce, and this could even include graduate students and postdocs, depending on on their area. They enter the workforce and then suddenly they're in charge of creating a data set like this. In fact, as he points out, sometimes what happens is in somebody's graduate work, they are using something like ImageNet, for instance, in their coursework or even in their research. But then they get to, let's say, a big car company, and they certainly can't use that data. They have to start from scratch, and managing this is not trivial. In fact, there's a lot of pretty heavy math involved in dealing with the quality control. Sometimes what you want to have is have two annotators do the same annotation, and then you have to compare those two entries to see if the lack of correspondence is great enough to be concerned, either on a particular image or on the process overall. So there's a lot to it. So I got super curious about this. Now, granted, this is only a couple hundred people and it's a convenient sample, but it's a couple of hundred folks in my feed on LinkedIn. And, those are, there's just a few thousand people, in there, but they tend to be either working data scientists or folks that are currently pursuing a data science education. So it's kind of, even though it's a convenient sample, it's kind of the right group to ask. And for quite a few of them, human in the loop just wasn't on their radar. Now, naturally, you might have different terms for the same kinds of things. There could be that. But I think it goes deeper than that. I just think this is something that we just don't talk about a lot. Oh, I also want to mention this. So if you get somebody that's been doing, let's say, radiology slides for months, and they've done thousands of these. They develop an expertise that certainly doesn't make them a radiologist. They're not the same as a medical doctor, but they actually have an ability to perceive things that in some ways is just as powerful, although very different from somebody like a medical doctor. So for instance, a medical doctor might ignore certain things that aren't relevant to the diagnosis, would be appropriate. That's why they get as much training as they get. But what a data annotator might notice is that, wow, the first 1,000 that we did were generally darker than the second 1,000 that we did, because I think we all know that illumination or something that's not relevant to the diagnosis per se could trick the deep learning network into seeing a difference where there's not a difference there. There's a famous example of this. It's kind of scary, actually, that you can find on the web. There was a famous instance where the word portable appeared on X-ray slides. And the reason that that was the case is that you use a portable X-ray machine when the patient is so ill that they can't make an appointment where they have a scan performed. The person performing the scan has to come to them. So obviously they're more ill. So it was a confounding variable, and deep learning doesn't know what it's looking at. It's amazing at finding patterns, but it was picking up on this word portable, which obviously wouldn't be directly relevant to the diagnosis. What I'm saying is, don't underestimate the value that the data annotators have with the experience that they develop over months or maybe longer of having a particular specialty, like autonomous vehicle footage or drone footage or medical AI slides. They make sure that there's a feedback loop from those individuals back to the experts like the medical doctor and back to the people that are building the model as well, because they have a point of view that you don't want to lose. Also, and I think this is obvious, if they've only done it for a week, it's not the same as if they specialize in a particular task or a particular project and they've done it for a long time, right? Those are obviously not the same situation. So take a look at this, for instance. I am not a medical professional in this field, but you can see obviously that there is an issue going on with posture here. And think about the rate at which this is happening. An expert annotator can process, and this would be, perhaps red dots appearing, at the hip and at the knee and so on, trying to look at alignment issues. But I know that I would not. I don't think I would be particularly good at this task, to be honest. Staying on task and doing the same thing repeatedly, I think would just not be something that I recognize in myself I would be especially good at. But imagine doing 45 per hour and how attentive you have to be to the specific task here to accurately annotate at that speed. Okay, so what I want to close on, so that we have a little bit of time to take questions in chat and so on, is just give you a couple of fun examples of some use cases, and again, to help you picture what it's like to do this. Imagine, again, doing this hundreds or thousands of times. So the image on the right has been processed with a bounding box type technology. And again, look at the volume, the speed at which this is being done, and the accuracy that is expected. And as you can probably guess, if you know anything about how this stuff is used in ag tech, this can spot the presence of disease or perhaps a lack of water to the plant. And all things that can allow you to marshal resources more accurately, like the amount of pesticide or the amount of irrigation and so on, or when the irrigation perhaps would occur, or when the plant is in some kind of distress. I was actually just having a conversation with an expert in hops. Hops is the plant that provides the flavor to certain kinds of beer. And what they were saying is that you would think you're looking for something like a droopy leaf or something like that. But they said by the time you spot that, the plant's already in distress. What they are focused on is trying to spot the emergence of buds and cones so that they can very carefully time the phase change between early growth and the productive cycle, reproductive cycle of the plant. Because if the plant enters the reproductive cycle too early and doesn't have sufficient biomass, it reduces the yield. Anyway, I thought that was really interesting. So, who knew that you would take these cameras and aim them at a row of a whole bunch of plants, and you're looking for the earliest appearance of a bud on the plant. I noticed the comment that just show up in Q&A. Perhaps we can do that when I'm done at the end. I think we'll have time for that. This is another cool one. I think we're all familiar with the stores where you have your phone app and you go in and you acknowledge your presence, and then you just grab things and walk out and you're automatically charged. And everybody describes that it feels like stealing, that it feels kind of creepy, but these kinds of stores are quite popular. But what we're looking at is not that. This is a less well-known case. This is actually an app that was developed using computer vision to help the blind go shopping at a traditional grocery store, which I think is really exciting stuff. And then, this is perhaps a kind of a personal example. I just think this is so interesting. Some experts in autonomous vehicles, they disagree on where the future is going to take us, but this particular theory is something that I just personally find very attractive. A number of autonomous vehicle experts believe that what it's actually going to do is increase the amount of how pedestrian friendly our cities are. And that might seem, ironic if, cars and pedestrians sometimes don't mix. Well, the feeling is that autonomous vehicles, and this is where they're placing a bet and where they don't all agree. Some people think that autonomous vehicles are going to be more focused on public. So driverless shuttles before technologies like us each owning an individual, car. And again, everybody's speculating about where the industry is going to go. But Paris seems to have some belief that this might be the way to go. This is the famous Champs-Élysées in Paris, and over on one side where you can see the lights at night. I'm trying to, if you haven't seen it, I'm sure many of you have. It's a beautiful place. But I'll tell you, when it's rush hour, we're talking, I can't even remember how many lanes of traffic, probably at least 8. You get a sense that there's a lot of intense activity going on there. Well, this stretch of road in Paris is going to be made pedestrian only. It's not yet, but they've done kind of these festival days where they, what do they call it? They call it Journée sans voiture, day without cars. And you see a picture of that there, but they're going to do this permanently, and they're going to completely restructure the Champs-Élysées so it's pedestrian only, which I think is amazing. And it's anticipation of how cities are going to change. So this is a gentleman that I just think is fascinating. His book is one that certainly I'd recommend, Smart Cities for Dummies, and he does the conference circuit with all the smart cities. And I interviewed him about this, and he made this pretty amazing claim that if you have a young child in your life that of 2 or 3 years old, that they'll probably never buy a car based on all of these factors. So I've got a quick summary there, but I want to make sure I have time for at least one question, and I may have not done that successfully. We'll see, but I'll stop sharing.